Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are back this week with some camera code, probably today, I don't know, because we kind of started the camera code last week, and I have some more things I would like to do to it this week. There's some restructuring I wanted to do to it. There was also like a sort of discontinuity bug that I wanted to fix, and then we can just improve generally the quality of it. But there's a bunch of other things that I was thinking of that I kind of wanted to get to as well. So I don't know, today's episode might be a little bit of a potpourri. That fabulous smell that your grandmother's bathroom smells of because she has that weird floral stuff, kind of above the toilet. It's that kind of episode, kind of like above your grandma's toilet. Let's go ahead and jump in here. I'll talk about a couple things I wanted to do. Today is day 379. So if you're following along at home, you want to follow along with start with day 378 source code. That's the source code that I'm starting with here. I will point out we did have, and I probably want to do this first if it is the case, just because someone took the time to write it in. Someone was pointing out, because we haven't gone and looked yet at re-enabling sort of the clip-rec stuff. I briefly touched on it in the Q&A last time because someone asked about it, but I had never looked at it myself. Snoring Tortoise wrote in and said, hey, I think it's just a question of like passing some parameters wrong. You changed some stuff and you haven't updated the way that the calls work. And so I figure since I know that people, I don't actually know why they were asking about running the profiler again, but I know that they were asking for it. And so since other people are apparently using that at the moment, I feel like we might as well re-enable it for them if this is actually the only bug in there, because, hey, I can go fix this bug really trivially, and then the people who wanted to use the profiler can use it. So in advance of us actually getting to the debug system and looking at it in more detail. So if we go ahead and take a look at what that mail was talking about, you can see that when I build this here, we have, oops, if I spell Microsoft Developer Studio's command line tool name correctly, that when I run this, if I wanted to go to the profiler, you can see that although things are drawing in the debug view, you can see that there's like this weird behavior of the profile rectangle, of the profiler's clip rectangle, where it's not really showing the things right. It's like the rectangle is this sort of darkened region here, but then we've got this like listing that's getting half clipped, what's going on. And the reason there is we never really updated the clip rec code to be correct once we updated ourselves to the 3D pipeline. Now what the mail is talking about though is that they were saying, well, I don't know that there's actually anything wrong now that you updated that, because in the Q&A I went and fixed the projection code to do a reverse projection for the clip recs. But they were basically saying that, hey, I don't know that there's anything actually wrong with that. I think you're passing the rectangle information wrong now, because it's offset and dimension here, and it's rectangle here, and blah, blah, blah. So if I may read the mail, you can see what they said. I believe the issue with the clipping on the profile is due to the get center rectangle being passed from rectangle 2i get clip rect into rectangle 2i get clip rect. This is an issue because the latter function assumes the data passed is min-max without modification. Two simple approaches to fix this are either to change get center rectangle to rectangle min, or change the calculation of min corner and max corner in the resulting code. So you can see these two here, and you can see how these are being done. It is correct that exactly saying the offset and the dimension, this is being interpreted as a corner. And that probably was just because I read it when we were doing it here, and I just wanted to do that, or something like this. I probably didn't think too hard about it, because we just did it in the Q&A last time. And then you can see here, when we do get clip rect, this rectangle 2 that's being specified here, you can see that it's turning that rectangle into a center point and a dimension. So probably the easiest thing to do in this case would be to pass a min and a max, because since that's what's already getting done here, it seems like maybe that's the best thing to do. I don't really know. It depends on how we imagine these functions to be used. But here we go. Let's just try it this way instead. Oops. So if we do rectangle min here, then this offset will now be the minimum corner as expected, and the dimension will just go out from that, and we'll see how that works. Okay. So I've made that change, and I believe that corresponds to suggestion 1, right? This would have been to change the other routine. Suggestion 2 would be to change the other routine. And hey, look, they are totally on point, or on fleek, as we might say. That is exactly the problem. And it looks like we still have some other issues we might want to address. Like you can see our tooltip still doesn't work properly. That I don't think has anything to do with cliprex. I believe that is just because our draw order is not in any particularly smart state at the moment. So we have some issues here to do with that. So what I might suggest is, since Snoring Tortoise went through the trouble of writing in to tell us how to fix this, it seems like maybe the least we can do, assuming that he cares about it or she cares about it at all, is just to go ahead and change those draw orders. So for example, in here we have some debug text. I think it's called TextOp there. I think that's the one. So I think most of our text is going through TextOp. I'm not 100% sure about that, but you can see that the only 2 push bitmap calls in here are right there. And in here, you can see that there's only 1, and it's for drawing an actual bitmap. So I think pretty much 100% of the text flows through this line. And what you can see about this line is that this line actually does a push bitmap of 2 lines of text, one of which is the drop shadow, and one of which is the actual white text on top. And we're actually drawing these at the same z value because we got rid of the shadow transform, text transform stuff doing anything in particular. And I don't think I really want to think about that too hard necessarily, but I think what we probably could do is just say, if we want this working again, then when we set that shadow transform, instead of default flat transform, all we really have to do is offset these by a little bit of z. And I think that that just fixes the problem. Don't quote me on this. I don't really know, but I think it's probably true. So again, I don't really know what order these are supposed to go in. I'm going to have to think about that a little bit. Backing, shadow, UI, text, tooltip seems likely. I don't know. But so you could imagine us just assigning these literally unit increments in z, like so. And those would just sort of get closer to the camera as we went. Similarly, if we wanted to make these be things that went further away, we could do something like this instead. Now, I don't know what we set up for the z range is the only thing. For clipping our orthographic transform, if I remember correctly, we didn't really do much with near and far clip planes. So what we did is we just hard-coded them here to -100, 100, which means that basically anything that we want to put in here will be fine as long as it doesn't overflow that value, I think. So let's just try this first, because the z buffer should, in theory, sort these things for us, would be my assumption. So now we can see, just looking at this, it looks like they are sorted properly now, and that's good. It looks like our tooltip is still a little bit busted, so we may have to look at that one, but the text itself appears correct, and so maybe we can just go in there and take a look at the tooltips, because that seems to be the only thing that is now incorrect, right? All the rest of this stuff looks like it's working pretty good. We can pick properly in here and look at our various debug frames. We can size this window. We can even hover and get a tooltip, but we just don't see the tooltip, right? So I don't know. We'll have to take a little bit of a gander over here at what's going on, because I don't know what's going on in this code anymore. It was a long time since we touched it. So what I'd like to do is take a look at, say, for example, the profiler, just so I can remember what we were even doing with z in there, whether we were setting z. I just am literally looking at the code here to just refamiliarize myself a little bit with what this code was doing. So what you can see here is there is a base z value, and we're actually using z as a sort. This is what I was suspicious of here. So what that means is z value-wise, we are actually doing a bunch of stuff with the z value to do sorting. And so it does suggest to me that what we probably need to do in this case is give ourselves plenty of room here. And in order to do that, we will need, because we're using z inside of individual elements to do sorting. And so that seems like an important thing, if that makes sense. So what we want to do from there out, and again, if this is 100 minus 10, the depth remaining thing, we're going to need a lot of range. So what we can do in this case is, again, just if we just give ourselves a large window of the near and far clip plane, we should be OK to use those for sorting values like we were using, I suspect. So I just want to double check to make sure that doesn't ruin any of the stuff that we were doing. It doesn't look like it does, and so that's a good thing. And now we've got more room in the Z range for any individual element because we were using those, as it turns out. So now what you can see when I'm sort of hovering over these is that the tooltip itself now appears to be working correctly as far as sorting on top of these things. So the only real problem with our tooltip is that the text of the tooltip appears to be drawing underneath the tooltip itself. And the reason we're not seeing that as a result is the Z will kill it. So what you have to remember, and sometimes when you see these results, especially if you haven't programmed graphics very much in the past, you can see things that seem kind of confusing, because they don't conform to any sort of real-world thing that you would expect to see. And so let me just take a brief moment, since we're seeing one of them now, to just try and articulate what's going on here. You can see as I move over here for the tooltip, you can see that the rectangle for the tooltip is drawing. And I don't know if you can see this on the video as well, because maybe the compression artifacts are too bad. But hopefully, if you're maximized and you're at 1080p, full stream, source, whatever, hopefully you will see this. You can see what's behind the tooltip, right? So here might be the best example of it for you. If I grab a tooltip there, you can even see the level moving around behind it, or like the blue bar of the cube behind it. So what you can tell from this is that we are seeing what is behind the tooltip. So the tooltip is drawing in a modulated blend mode, and it's darkening whatever was in the frame buffer prior to it being drawn. Okay? So now, if you were thinking of this strictly as a real-world analog, where I'm holding up, say, a translucent or transparent, in this case transparent, piece of cellophane or something that just happens to be dark, so it cuts down the light a little bit, but otherwise you can see through it. What you would expect to see here, if the text were drawing behind it for the tooltip, is you'd expect to see a darkened version of the text. And in fact, you can see a darkened version of the other text behind it that was drawn as part of the profile window. You just can't see a darkened version of this text, right? And so what's important to ask ourselves here is, does that imply that the text is either being clipped or not drawn at all? And the answer is no. In our case, that doesn't actually imply that. And the reason that it doesn't imply that is because, remember, we are using a Z buffer. That means that every time a pixel is drawn, it's going to test to see whether the Z value of what is already in the frame buffer at that location is higher or lower than the individual object that's, is higher or lower than the thing that we're drawing now, right? And furthermore, we have a multi-sample buffer on, and the multi-sample buffer will look to see whether or not individual samples are. We're also using alpha to coverage. And what that means is our alpha to coverage will be making it so that 8 steps, I think that's how many we got on this machine, is 8 levels of 8 samples per pixel. Alpha to coverage will be randomly setting those 8 samples, well, pseudo-randomly setting those 8 samples. How many of it will cover for any given pixel is based on the opacity of the thing being drawn. So given that all of those things are in play, what we don't actually know in any given circumstance is exactly what, if we don't know what order the things are being drawn in, right? If the Z value of one thing is underneath the Z value of another, it depends on the order in which those things get drawn, whether or not we will see them show through or not. Now, in this case, we have to think through it very carefully, because it does seem to suggest that we should see something showing through. And the reason that we probably should see something showing through is because whatever the opacity of this thing is, we know that it hasn't fallen below the 8 samples per pixel threshold, because when we move it over something that we can see, like this begin world change, right? It's obviously not so opaque that it covers all 8 samples. If it did cover all 8 samples, we would not see anything behind it at all, right? It would just look black. But since we can see something behind it, that means at least one of those 8 multi-samples is not getting covered, right? Okay. So what we would expect to see then, in this case, is even if we were to draw the thing afterwards, which I'm assuming must be happening here, right? Or sorry, even if we were to draw the thing beforehand and then draw the thing on top of it, we would be expecting to see that thing show up dimly below it, right? But here's another option of what can happen in this case. If if we were to draw these in the other order, right? So let's say we were drawing these two things in the opposite order. So we're going to draw, well, even in that case, I don't think it would happen. Yeah, strike what I was about to say. But another thing that can happen here, right? I just want to point that out, is the Z buffer also will kill anything we're trying to draw that is below something that we already drew. So in the case that we had accidentally, let's say, set the text to draw behind the tooltip bar, which I don't think it'd be possible because presumably it wouldn't have shown up in our previous rendering, but let's say we did that, we could expect to see nothing there. And the reason we could expect to see nothing there is that even though the version of the tooltip backdrop is not opaque, right? And what it's going to show is when it kind of goes over something, it's going to dim it. The things that it will dim have to be things that have already been drawn. They have to be earlier in the draw order because OpenGL is not sorting anything for us. It's just using a Z buffer to resolve the depth. What that means is that when the text comes, if the text were to have a Z value lower than the rectangle, all of the pixels for the text would get rejected because they would always think they were behind it. So not only would they not draw on top of it, but they actually wouldn't draw at all because it has laid down a solid rectangle of Z that is higher than the text. And that appears to be what we're seeing here, but we could also just be seeing a clipping problem, right, where the text is getting clipped. The reason I think that it's not a Z sorting problem is, again, it doesn't seem like the tooltip would have worked in our previous renderer, which was sorting, if the Z value was less. But who knows? I just wanted to point all that stuff out about how it's a little confusing there because the Z buffer is a comparison and a rejection, not a sort. You can get situations where it appears like something should be drawing one way or another, and it's in fact drawing in neither way, right? So you might think that you would always see either the text dimly behind the rectangle or the text in front of the rectangle, but not just no text at all, if you were in fact drawing it properly with no clipping. That is actually deceptively not the case because there's plenty of ways with the Z buffer that could actually occur, right? That's the only part I wanted to get out there. Again, crazy graphics bugs, just something to be aware of. So anyway, let's take a look at the tooltip situation. I think that's in here. If I remember, it was down at the bottom. Yes, it is. So let's go ahead and take a look at what's going on there. In fact, let me move it over here so my head's not ever going to be in the way. And let's take a look at what's going on here. So you can see here that we're passing the tooltip transform as the place we want to draw this text. We're drawing some stuff here, but I don't really know. It's a little bit weird. We've got a hard-coded, that's probably the problem. We've got a hard-coded value for the text here, which doesn't seem particularly bright. I can't say that sounds smart. And so probably all that we're seeing here, literally what we're seeing here is the clipping, like I was saying before. Like I said, it's a suggested clipping. Turns out it was clipping. It's not clipping in the clip rectangle sense, which makes sense why it didn't get fixed when we fix the clipping rectangles. What's actually happening here is it's clipping outside of the Z range. So you can see that this is being given 110,000 in Z, but we only allow in our transform, if you go back to the math functions, we only allow 10,000 as the maximum value. And so what ends up happening is it's past the far clip plane and just gets clipped. It gets clipped in Z, not in X and Y, but in Z. And so that's really our only problem here, and I wonder why we had to do this in the first place. I don't really know why. I'm not sure why we couldn't just use the tooltip transform itself. Probably had something to do with the way we were sorting before, or maybe this was just an expedient way to do it. It's the debug system, so hey, nobody probably cared, especially not me. But at this point, we do care because we want it to work again in our system because we'd like to see our tooltips. Now, what's interesting is the text out at function here. I'm not really sure why it doesn't take one of these transforms. I would like to take a look and see how we were calling that most of the time, just to find out why it's not just taking a transform as normal. I'm not sure why that would be, but let's take a look. So here's text out at. and you can see that all it does is call text-op, and it uses an @z here. The p is just a regular p value. And when we come through here, it's going to call push bitmap. It's going to have to pass a transform of some kind. And it looks like, okay, so here you can see it does shadow transform, text transform. So this is kind of a nutso way to do this if you think about it. What's really happening here is that these two transforms are assuming that the transforms are just, automatically going to be in some plane of text, and the z just sorts within that. That doesn't seem particularly bright. That doesn't seem like a particularly smart thing to do. I also don't really know where the actual z value here is getting applied. You can see the @z. Let's take a look here. So it's getting put into that bitmap offset, right? There's that @z. So we're effectively taking the transform and the text transform and just using those as baselines, and then we're using this @z to sort of rebase where the things are. Again, I think that was probably something we had to do because we were trying to, use our old wacky 2.5D system. That doesn't seem to be particularly smart to me. I'm not even sure why we would have two planes for the shadow and the regular text before. It doesn't really make a whole lot of sense, honestly. So I kind of feel like this whole system wants to be simplified now that it can be. I'm going to take a quick gander. I just want to know. If I take a look at all the places we call text out at, I'm just curious as to how they're used. So you can see here we've got a basic text element one. And in the basic text element one, I guess we don't really pass in a z of any kind. So when we're just doing basic text elements, it looks like we're sort of just not really doing any kind of text element stuff there. We got the one in the tooltip, which is busted, as we know, and we know why it's broken now. We have this one here that's the string that kind of just shows up at the top of the screen as like a permanent reminder of what our frame rate and memory footprints and things like this. That's all that does. We then have a text out at that we're using right here to sort of show us, hey, okay, here's the tree that we view all our stuff in. And this is the case of a group. This is like if there's a group, it'll draw the name of the group. But I think that's basically it, right? This, I don't know what this is. This is old radial menu stuff, which we don't use anymore. So that's just not a concern. It's not even the same function. So there's not a lot of places this is getting called. So it wouldn't really be out of the question to just start having it pass a z value that was sensible and get us out of the business of this shadow transform, text transform stuff, which doesn't really make a whole lot of sense to me. Because I feel like we should always inherit this z a little bit more explicitly. So I would kind of be interested in doing that. Again, I want to see in basic text element, the only problem there is for basic text element, I don't really know if the people have been leaning on this fact that they can get z values, in a convenient way here. Because none of these, all of these things kind of just assume a sort of basic z-ness. And I don't really know. Here's where, for example, we make those like Boolean buttons, right? And so I think everyone just assumes that the z is just a flat thing and it doesn't really stack on top of itself at all. I don't really know how smart that is. Maybe it is, maybe it isn't. It seems to me like it might be problematic in a few ways, but at the same time, maybe it's not. I don't really know. I guess what I would say is we can just fix the tooltips, or we can fix this a little bit more. Maybe what I'll do is just fix the tooltips, and hey, if it never becomes a problem, then we just don't look at it further. But you can kind of see why that's just a little bit weird, and probably not what we really wanted to do. So in here, if we said like, oh, okay, we just want the tooltips to be on top of everything else, that's all we were trying to do here. What I could say is, well, all right, when we initialize these things, shadow transform, we've got, here's all of our stuff. So if we want the z value for these things to sort of counteract the sort of normal shadow transform that we're seeing here, what we would need to do is like boost them over by 4,000. Like we'd have to like push them up, right, into the closer range. What I might say is, hey, eventually it's probably the right thing to go ahead and make Z flow through the debug system sensibly. But for now, we just don't care. And then I think we should now have our tooltips back, or rather the tooltip text back. Obviously, the tooltip rectangle's back. So there's that tooltip text working again, and you can look at the frames here and so on. I don't know that there's anything else particularly that we did with tooltips. I think it was just mostly for hover and the profiler. I don't know if there was any other thing that it did. So anyway, this seems to be working relatively well now. I think we can drill in here. And that works okay too. There wasn't a back button. I remember that was because it was hard to implement to know which was back, I guess. I don't really remember. There's something nasty about going backwards. I remember that. But anyway, yeah, you can see that we're pretty good to go here. We can look at anything we want now, and it looks like everything's back and working okay in the profiler. What is all this thing? World mode, some location, some font location. Sim region, handmade particles. It really bums me out that we don't get the function names anymore. All because LLVM and Clang are dumb, or I should say GCC. And the C++ spec, I suppose, because they kind of ratified that dumb decision. It really bums me out. That's the only reason we don't have the function names here, is because C++ is spec didn't provide access to a constant, like a string, an actual string literal for the function name. They only provide access to a variable name, which we couldn't concatenate on. And that was just the worst. Anyway, I had trouble drawing whatever that is. Go back to root. There we go. So anyway, we don't have the function names anymore, which is a bummer. I wonder if we could cheat and have an if-def in there that makes us get the function names on Windows, because I really like having the function names. I don't like having to go, okay, what's this, what's at Win32 handmade.cpp line 2402, right? It's like, okay, well, let's see. Win32 handmade.cpp, go to 2402. Okay, it's the game update block or whatever, right? Although I suppose that one's less bad, because that one at least was a string constant one. Handmade debug 1981. All right, it's debug end, right? So I want that to just say debug end, and that's what it used to do before we had to fix it for trying not to get too upset about people who do C++ stuff literally making the wrong decision in every possible circumstance they ever can, which is kind of like some kind of unbroken streak. It's like the longest unbroken streak of bad decisions that we've had in history. It's probably like U.S. foreign policy followed by the C++ Standards Committee. All right, so let's see. What if we were to go to that just real quickly and take a look? It's actually in debug interface.h. The reason that that's happening now, if I remember correctly, is like when we build these debug names, we do this sort of nonsense here, right? File line counter name, like that. And I guess we don't stick D in there like because that is sometimes __ function, right? And so what we could do here, I think, if we wanted to, is we could do something like if handmade win32, because I think we have that. I could do something, I think, where that actually works, right? So on handmade win32, we stick that on the end. I don't know if that'll work. I'm going to see if it does. Maybe it does, maybe it doesn't. There we go. So that way we can have those on Win32, right? And it'll always show them. Yeah. Now I suppose the other thing is maybe we're still getting that information through a secondary source, because I guess one thing that's interesting is here are the timed regions. And if I don't do that, so if I don't have Win32, and so the build, right, that's set in here. So that way, you know, people who are compiling other platforms won't have to worry. If I do force it to the other way, I guess the thing I'm not sure about is what does the profile do in that situation? How is the profile getting this information? How is it getting the function name here? You know what I'm saying? That must be stored in an additional location. Because in here, it like doesn't know that now, but in here it does. So I guess like we worked around this problem, and then I guess we didn't port it forward when we had, because we only worked around it for platform portability, and it was after we'd already finished everything. So I guess it has to do with the fact that the name gets stored here. So that's it. So we still do store the name here. We just don't concatenate it on. Right? So in theory, I should be able to get that piece of information back in the debug layer where we do the tooltip, I think. So for example, on here where we've got tooltip like this, where we do element GUID, in theory, if I did element name, I would get that back. So maybe I don't have to be too grumpy about this, because maybe we already solved the problem for all intents and purposes, and I can save my extreme hostility for the C++ people for one of the other many myriad times where it was like not something you could work around. So let's go ahead and just try it this way. Put that back. Well, I guess I can just leave it back to the original way it was, like so. So maybe what I can do here is say, yeah, in this case, let's print out the element name as well, which I don't actually know exactly what that is. So in this case, I'm going to have to look. It is just a char star. So I'll just say like that. And we'll see if that, now which one did I just update there? I don't even remember which function I was in. Profile bars. So I believe if I go to profile here, and then I'm in here, so there we go. So then we can get it back, right? By just like sticking that additional bar piece on there. And then similarly, I should be able to do that in the other case where we had the tooltip, again right here. Because we already did the work to work around this, so that's good. That way it'll work on Linux as well, which is nice too, for people who want to be able to use this. So let's see. Looking at this here on the frames one, there we go. You can see debug collation frame display, game update. Perfect. Here we've got them too. And I think those are the only places we had it. This was just to say which frame index it was, just to aid in debugging there. And the clocks here didn't ever print one out. It was already on the screen. So this one was just one that says, here's how many cycles. It was cumulative, right? I'm sorry. Here's how many cycles it was per call, like that number divided by the call count, and then what the cumulative percentage was. So you can kind of see, like, okay, cumulative up to its 90% right here is where it ends. You know, what's kind of interesting about looking at this is update and render entities takes a lot of time now, which is kind of cool. Now that our profiler is back and working, we can see the 30% of the time is spent there, which is pretty interesting, actually, right? I'm not sure why, and it would be interesting to know why. It would be interesting to take a look at what was costing that time in a little more detail. And in fact, why don't we go ahead and do that? So we're not compiling in debug mode. I'm sorry, we are compiling in debug mode, right? So that's fine. And I'm going to go ahead and go to update and render entities. Let's take a look at that call. Here it is. You can see the timed function bit here. And we go through each of the entities individually. We do the boost code here, which we don't really need to do anymore. but it's still kind of happening. We have the physics part here. We've got the render part here. And then we've got the debug pick entity part here. And so what might be nice at this point is to do a little, sort of begin block instrumentation and just kind of take a look at where exactly we're getting that time, where that time is getting sucked away, right? So let's see. We know that we're only going to process active entities. So let's just do some quick instrumentation here. So there's the begin block, end block. And there's all that stuff. And inside there, we actually have, during the render, we've got this debug as well. So I'm just going to go ahead and give those a little prefixes because, hey, we don't know that they're entity-based at the moment. If we just saw them show up on the profile and weren't sure what we had been doing at that time, we'd be like, what? Physics? What? So at least now we can see that they're specific to this. All right, so this should give us a little bit more granularity there in terms of the profiling, so we can kind of see what's going on. That's weird. Did I miss a closing block? Begin block, end block, begin block, end block, begin block. Yes, I did. There we go. Try that one more time. So it looks like here what we can kind of see is that none of these things, they're all kind of down in the noise. So it's really only the entity render call that is doing anything particularly substantial. So we kind of know exactly where our situation is. And if we take a look here, you can kind of see, debug end is not something that and debug collation are things that are processing like tons of entries and doing a bunch of stuff. And we don't care so much about those. But these two right here we do kind of care about because we want to make sure that nothing particularly nefarious is going on in there. OpenGL render commands is also a little bit suspicious at that point. I'm not sure. We may want to take a look at what's going on in there because that should be made relatively efficient. I don't know. It depends on whether the GL texture changes and stuff like that are taking too much time and who knows what. Not in terms of the actual rendering, but I just mean in terms of going through the driver and doing the handle translation and stuff like that. But let's take a look, because for only 510 calls, it's taking us 60,000 cycles to do these. And so it just seems like, well, I'd like to know that that was appropriate, because I don't know that it necessarily was, right? So some things that are interesting in here, you can see that we're creating some vectors and doing matches on them. I don't know if get match bitmap from... That's a very slow and unoptimized and pretty stupid call, really. So I'd be interested to know how much time that was taking. And then when we look on here, we've kind of got some other fairly straightforward stuff, I think. Just pushing on, nothing particularly interesting going on there. Just, pushing volume outline and stuff like that. So who knows how much time those things take. I would like to know about that get best match bitmap from. I'm assuming that it's not really taking too much of a problem. Okay, so there it is. It's already been removed. That's already a timed function and is not taking... Because I was going to say, I feel like that function will have to optimize eventually, but we just don't have very many assets in the system right now. And so since we don't have very many assets, we wouldn't expect it to take long to iterate through them, right? Let me pause this for a second. So you can see right here, there's the function, and it's not taking any time. So we're really talking about this entity render here. We don't really know what the more specific elements of that are. So we probably need to investigate even further to see what is the slow point. So since we know that in here, let's see, we're going to go through here, get best bitmap from, push cube, push bitmap. I guess we know we sort of have some of these. I'm going to get rid of these ifs. I don't know. We don't really need them at the moment. We're not doing that one. So we really only have 2 here. I'm going to go ahead and just see if I can isolate this a little bit further. So let's go ahead and do, you know, render pieces. Render hit points. Render volume. And now I've kind of got this like marked up pretty explicitly, so we should be able to see if it's an even spread or what. So now if I pause, we can see render volume takes quite a lot of time, but render pieces also does. So both of those are pretty slow, actually. So what I'd like to do is take a look in there, because those are just both basic render calls. I'd like to kind of know what's going on in there that's making them so slow. So if we go to get best, if we know that that's not taking any time, we know that this is probably not taking any time because it's literally just dereferencing some values. Push cube and push bitmap are really our only sort of suspicious entities here. And I suspect, you know, it could just be the case that because unoptimized, these are going to go through tons of calls and lots of unnecessary copies and stuff like that. It could just be that that's just too much, right? But I want to make sure that's the case before I say so for sure, and that there isn't something else going on that's you know, more suspicious, if that makes sense. So let's take a look at what's going on there. Just looking through here. I mean, I can sort of see, I mean, there really isn't much to say about these functions. They're just pretty much writing stuff out, extremely straightforward. So I don't know that there's all that much to say. It may just be that there's just too many function calls in here that, of course, don't get inlined when you're not in release mode. And if I look here at, you know, get current quads, for example, I mean, again, just nothing happening. So I'm pretty sure all of these things are basically harmless. I'm going to verify that by switching to O2 so that once those are inlined, I want to see what happens. So again, pushes that way up in the top there, but render pieces is still pretty substantial at 10%. I'm not really sure for 500 for that 8,000 cycles is an appropriate number of cycles just for pushing some floats around. But again, it's a little bit hard to tell without further analysis of it. So if I take a look at here, and again, all I'm doing is sort of looking to see if there's anything particularly unusual about what we're doing. I might want to take just a quick gander in optimized mode, mind you, of what the compiler has actually generated here, just to give myself a little bit of insight into like what actually is going on in here. So if we step into render pieces, for example, and I'm going to go to the disassembly here. You know, here's the code for push cube, and you know, you can see here that we're going to skip over this. Let's see here, and see if we're going to make any calls. This is actually the call to push bitmap. So that's going to look at the asset there. That's going to go. So I got to let this run so it can load some assets. It's going to skip load assets on the. It's going to skip rendering a bunch on the first frame because it hasn't had anything loaded yet. All right. So let's go in now so we can see one of the calls. Here's the call to get asset. It will succeed this time. And now I'm going to look at that call to push bitmap. So here it is, right? I'm stepping into push bitmap here, and we can sort of see us testing what's going on. Here's the check against the bitmap width and height to make sure that there is a bitmap to push. We probably don't really need that anymore, but you know, we probably could just let it go. But here we are calling get bitmap dim, and that looks like it was not inlined, right? So it's actually calling out to get bitmap dim. Now, that's a little weird. And I'll be honest, I wouldn't have expected quite so much work to be done here. This could probably be done a lot better. You can just see there's just a lot of fussing. Just a lot of fussing. It did inline get render entity basis p, which again is very, very straightforward, I believe now, because we basically gutted it. It's just this. We gutted it so much, in fact, that I don't know if object transform is even worth it anymore. Like, it kind of feels like this maybe wants to go away entirely and object transform should just be banished. But, you know, it did inline that, but that's literally just a you know, trivial operation. But you look and there's just a lot here. And to be honest, I'm not really sure that just some multiplies and subtracts would account for all of this. You know, let's do a little experiment here, shall we? I'm just, you know, I'm kind of interested in, you know, since we happen to be in the middle of it, I'm just going to go ahead and see. So, you know, here's get bitmap dim, right? There it is, well, it actually goes to here. I'm gonna just cut and paste that, and I'm gonna cut and paste it into the scratch buffer. So you can see get bitmap dim here, and here's all the instructions for it. And maybe that was a reasonable number of instructions, and maybe it wasn't. What I want to do here is I'm going to go to get bitmap dim now, which is this code here. And all I'm going to do is I'm just going to rewrite it without using any C++, right? I'm just going to use straight C, and that's all I'm going to do. And I want to make sure that there isn't anything funny going on here. So if we take a look at what's going to get produced for size, it's you know, size is a v2, right? In fact, I'll just go ahead and do it this way, so we can generate either version. And so if I reproduce this, I can just say, well, all right, the x size is going to be the height times the bitmap width over height, right? That's just a multiply. And the size in y is going to be the regular height. That's all we were trying to do here, right? The alignment, you can see here, is the Hadamard product of the align percentage and the size times the C-align. Again, that is just a 2D equation, right? And so the Hadamard product is just multiplying these two things. So really all that's happening here is this, right? You're just, I mean, there's nothing, that's all that's happening. The Z is getting copied directly. The X and the Y, again, are doing a very straightforward equation, like so. And that's really all we're talking about here. And then get render entity basis p is really just this. Oops. So it's just adding the two together. And so just adding the two together is really trivial, right? It's this. And so all I want to do there is just do them explicitly. And so that's what this function looks like without C++, right? So without operator overloading of any kind, this is the actual set of operations that's occurring. Don't know why I just did that. So that's everything. So I'm going to compile this. What did I do wrong there? Is object transform, sorry. There we go. So that's really all there is to it. And we'll have another there'd be another sort of thing I could do there that I'll do in a second, but I'm going to go ahead and do this again. And I just want to see if it really was correct to assume that much stuff get bitmapped in. Okay, so that's very interesting already. You notice I couldn't set a breakpoint there. And what that suggests to me is that now it has been inlined. And previously it had not been inlined. And that's a very interesting thing, right? So here we go. So let's take a look here where here's that call to push bitmap, same call. And here we go, right? Here's push bitmap. What you can see oh God. What you can see is that the exact same set of SSA operations now produces inline code, which hadn't been inline before. Probably because it couldn't know that well, no, I mean, it can't be an aliasing issue because we're still leaving everything in the structs and we didn't pull anything out to a temporary variable. I have no idea. I guess I don't know why the compiler didn't know that those two sequences were the same, but hey, guess what? Now there isn't a function call to that function. I wish I could say that was surprising, but it didn't surprise me, and you know that it didn't surprise me because that's why I took the step of writing it out explicitly. Not fabulous. So if I now pause, you can see that render pieces is still quite a bit of time. So it's not like we, did some major amazing optimization on it yet. But it's a little troubling, right, to see that literally I took the exact same piece of code, did nothing to it, and just the same SSA single static assignment. We haven't talked about it in Handmade here. I guess I shouldn't be using that term yet. But the same set of mathematical operations in one case is understood to be inlineable, in the other case it isn't. And I literally didn't do anything other than just expand this out in the same way that you would expand it out if you were to include those functions there. So that's not great. Just to be clear, that is not great. That is what we would call a not great thing. But let's continue to investigate further. All right, so we can't even compare apples to apples because the other one wasn't getting inlined and now this one is. So we don't even know how much of a difference that one made in terms of assembly, but I think it also probably resulted in less assembly code just in general. And again, that's because I think it was doing more operations than I felt like it should have been doing in that situation. Let's go to the disassembly here and just look. So it looks like it starts about here. It ends about here. So I don't know how much better that is. Here's that original version. I don't know how to... I guess I can come in here and just put it at the end. Here's the new version. So it's definitely simpler, although I don't know if it kind of elided some of those obstacles. I'm not being particularly meticulous here at looking at it, but you can see at least that, you know, I mean, this was very long before, right? I really do think this was doing more than necessary, and I feel like now it's down to sort of more like the number of operations I would expect, but again, I'm not being meticulous there, so it could have just stuck some of the ops further down, and so it's a little bit hard to say, right? All right. So looking at here, so that's one call, and now at least we're getting that call inlined, which I wanted. Let's take a look at the push quad call. I just want to know if that's getting inlined as well or not. Let's put that here. Where are we at here? So we are in push bitmap, which is where we want to be. However, it's pretty hard to isolate where it actually spread this code out to, unfortunately. But I guess that's good enough for now. Okay, so in the push quad call, it looks like this has been properly inlined as well. Aha. So I'm going to take a look at this saucy gentleman right here. Because I'll be honest, he does not look particularly good to me. In fact, what I might do is I might actually step back for a second and figure out what's going on here. So somehow, and I am not sure how, our rounding function is actually something that is not getting inlined. And so our color, I'm assuming this is due to the color conversion. Oops, I don't know what just happened. Hit some weird hotkey there. Let's go ahead and jump to the non-optimized version of this code, since we know that roundef is getting called. I don't really need the other version right now. So let's go to the disassembly here and see what's happening with that, with respect to that. So it should be in the call to RGBA pack 48x8. So let's jump in there, and you can see us calling round. And so here's an actual call to round. Oh boy. Oh my goodness. So this is just an epic disaster, right? So all we're trying to do is round a number to an integer to pack a color. So this is just real bad. I mean, look at this. We're going to actually eat this function call. We're going to do all this work. We're going to eat another function call to fdint. I don't even know where that is in the source code. Oh God, just, oh my Lord, no. All right, so that's really bad. Like that is really, really, really bad. When we're pushing sprites onto a list of things, that is just awful. And let's just go ahead and get rid of that right now. So I'm going to go find that roundef function and excise it from this code base immediately, because that is a really bad, very bad situation that is not good and is bad. The badness of it is exemplified by its being bad, and we don't want that. So you saw how much code there was there. It was multiple function calls. It was a call into roundf, multiple calls into fdint. There was a whole bunch of boilerplate. It couldn't be inlined. This is really bad. So roundf needs to go. Fortunately for us, we were smart at the beginning of our code base and didn't call roundf. We called round real32 to int32, so we have an even easier job for ourselves because we knew we were going to have to replace this someday, and that day is today. So the question is, if we just want to do a rounding function, so we want to take a floating point value and round it to an integer, how do we do that? Well, fortunately for us, back when we originally did this, we didn't know anything about SIMD. We know something about SIMD now. So we know about the Intel Intrinsics Guide. Oh, by the way, thank you, Snoring Tortoise. Forgot to close our bug there after we fixed it. So what we can do is, we all know about the Intel Intrinsics Guide, right? And where is mine? There it is. We all know about the Intel Intrinsics Guide, which gives us access to those nice intrinsics that we've been using. And what happens to be the case, and again, remember we are on SSE 2 is what we decided our platform was, so we can't go up to these saucy gentlemen right here. But we can use any of the other ones. It turns out that all of that work that was being done there with the craziness that you saw, we don't really need any of that work. That's the C runtime library's roundf function. We don't want to use that because well, you just saw what it was going to do. We want something that, we can be done much more quickly. How much more quickly can we do this? Well, it turns out that there's actually an actual function in SSE, a processor instruction for rounding. So it should really be one instruction to do what was previously taking hundreds of instructions and function calls and everything there. It should just be able to call just one of these. And so we should be able to round a floating point value with just going straight away. So let's take a look at that in a second here. I believe I can't remember the names of these here. Let me see if there's any way I can isolate them. It's like convert PS. We used it on the. In fact, you know what? It's right here, right? CVT TPS is, I believe, the one that does truncation, the extra T. Without the extra T, I believe it doesn't do truncation, it does rounding, right? So let's see here. It's convert PS EPI32. Convert packed single precision 3 Florinos in A to packed 32-bit integers and store the results in dest. And I believe it will just use whatever the mode is of the chip at that time, which will be rounding if we haven't set it to anything else. So this is all we really need to call. Now we don't need to do packed singles because we're only converting one, but I don't know if they have a convert SS F32. Do they? They do. So that's also in SSC2, and that's fine. So if we want to do a convert SS, in this case, let's see what this does. Convert the lower single precision floating point element into a 30-bit integer and store the result in dest. So convert SS SI32 should be what we want, and it should just provide the integer that we are looking for, right? So what we should be able to do here, I would hope, is to just say, okay, really all we wanted was convert SS SI32, set 1 PS real32. And so that's, I think, and I guess set 1 SS is really what we want. Set SS. All we really want to do is say, hey, take this float and round it, please. That would be nice of you. And presumably we can do this in either case. I don't actually know if there's a way to do this in a way that doesn't involve casting, because I don't think they provide any version that would do it that way. We just have to take the rounding one way or the other. Let's see. Yeah. So we're just going to have to do it that way. But I think that's all we need. So if we do that, in theory, we should be good. I don't actually know. Let's verify that our game is not all broken, but it doesn't appear to be broken. So now we've at least gotten rid of those calls. Let's take a quick look here, too, and see if that helps at all. It's getting better. Still not great, but it's getting better. So let's take a look now and see if we've gotten rid of that. Oh, that was good. I said that, and I was comparing the non-optimized version. Now let's see how our optimized version is now that we've gotten that call of roundef out of there. All right. Now you will notice that it has basically gotten slammed down from what I think started at 9% of the time down to 0.87% of the time. So I was right about. I was going to say removing that call, like multiple 4 calls to round outside of the inner part of that should have done a lot more, and it did. Okay. So I'll say a couple things about that because I think it's a really good illustration of a bunch of things that we've said many times on Handmade Hero, and they come up occasionally. So number one, how important is that profiling, right? We were very quickly able to zero in on what the problem was and know what was going wrong, right? So having a profiler always running is just great for awareness, right? Number two, being able to read the assembly, right? The only way I started to know what could be going on there is because I looked at the actual assembly language code. Now, I'm not a great assembly language programmer. I don't write very many things in assembly language ever. Most of the time, I just use intrinsics, which is not very good, right? It's a poor man's assembly. It's not as good nearly as writing things in assembly. But I can read it well enough to just get a basic idea of what the processor is doing and know when things are totally wrong, which in that case they were. We saw it fail to inline a function because of use of C++ features, a very common thing that you have to be aware of, and you need to pull back on those features when it's happening. And then we saw using the C runtime library to do a round not acceptable, because even though the C runtime library is built into the compiler and the compiler knows all about it, it's still doing a really stupid thing there, probably because of some requirements in the spec. Now, there's ways we probably could have forced it to do something less stupid there. So, for example, there are flags you can pass the compiler that say stuff like, don't try to be all that accurate with floating point numbers, and sometimes those will help make calls like roundef not have that problem. But in our case, we don't want to do that. What I'd much rather do is the thing I've said before, which is get rid of as many C runtime library calls as we can, because if we implemented them, then we know they're not doing anything too stupid. And if they are doing something stupid, we at least know what it is. We know our own stupidity. We don't know the compiler's stupidity, and we don't know the C runtime library's stupidity, but what we probably do know is that it knows no bounds. It can be as stupid in some cases as you could possibly imagine. In this case, that's one of them, because again, not because the people who wrote it were necessarily doing something dumb, but because they have to follow something that may be very stupid from our perspective, but that was the requirement for what they were doing. So happiness upon all happinesses now. Just from that minor investigation, what you will note is that we have dramatically reduced the degree to which any of those things was affecting our frame rate at all now, right? I think you can see that now we're up in just the platform layer and the debug layer are the only things taking any time. So let's pop back to debug mode and now see where we're at for our debug builds time usage, just to get a feel for it. So now we can see that render pieces and render volumes still do take a little bit more time than I think we would probably like. So let's just push a little deeper into those and see if there's anything we could do to make them in debug mode go faster, even though we don't care about that for shipping the game. It'd just be nice to know what was happening there. All right. So let's take a look. Probably just too many function calls, like a death by 1,000 function calls. But let's take a look inside. Say push volume is our worst offender at the moment. Of course, for some reason I can't find it. It is push volume, is it not? Render volume. Sorry, render volume. Nope. So render volume is exclusively calling push volume outline. And so push volume outline, it kind of makes sense why that's our worst case. It's doing a lot of these line segment doodads. And those line segment doodads obviously do a lot of nasty stuff, right? You can see in here we've got these like length things happening and all kinds of stuff like that. It's not great. And blah, blah, blah. Let's take a look at push line segment. Oh, and it's got two of these packs here going down. And so that's going to do a bunch of calls to round reel 32. But fortunately, at least we removed the really bad stuff from there. And in release mode, it'll be quite efficient, probably. So let's take a jump, a little gander, a little look-see, a little, you know, a little bit of a, just take a little bit of a gloved finger in here and just kind of feel around and see what we can palpate. What I'm going to do here is just, I'm going to skip over these because I think they're probably as good as they're going to get. Again, in release mode, I think they would compile down to very clean at the moment, although they could still be made cleaner, certainly. In fact, I could show you some stuff about that pretty easily. Anyway, we're doing some of these things here, the inner and so on. Functions, again, that's just going to be basic math. That's OK. Still calling down through. Again, these are just basic math ops. Let's take a look into that length. I'm just interested in what's going on there because that, you know, length does have a square root involved. So let's see what's happening here. There's our call to length squared. Again, that should just be math, nothing weird there, and an inner product. Again, nothing weird there, just basic math ops. So way too many function calls, but those should all go away in release mode. And based on the profile, it looks like mostly they were. But once we get out of here, then we're going to call square root. Square root is calling this, which I don't even want to hit F11 right now. I'm hitting it, and I'm sort of looking to the side. This is, again, C runtime library. Oh, so we don't have that, I guess. We don't have their square routine in here, so that's fine. We'll look at the assembly. So let's see what we do. OK, so mind you, square root is one instruction on an x64. Here's what the C runtime library is doing. Again, probably because it has to handle all kinds of weird cases. We skipped over this handle error case, so that's good. And then, hey, at the end of it, we finally issue squirt SS to actually do the square root. So at least it does the one instruction square root, which is nice. That's not that onerous. I didn't have I didn't need to squirm too much. Although, I mean, yeah, come on, you know, that's way too many for a square root. That should be one instruction. So let's replace that one too, just because we can. But at the moment, you know, not as egregious as I feared. Sometimes you step into a square root and you're just like, oh God, the horror, the humanity of it all, you know, and you're just like, you're just terrified. So I'm just going to scan through here to see if anything else particularly gnarly is happening. I don't suspect it is. Again, I think this is just a case of like death by 1,000 calls that would all be inlined in a normal circumstance and look like they are from our release mode profile. So not too concerning. Let's see here. Anything else happening down here? Not too much. So I'm going to go ahead and just fix that while we have the opportunity to do that as well. So let's see here. Is it in intrinsics? Squirt F. So there it is. So we've got our squirt F here. And I just want to change this to something that's a little more sane, like I said. So I'll fix it to our new naming scheme as well, so we know we've touched it recently. So all I really need to do here, again, is just lean on the fact that we have a square root instruction already. Here it is. It's squared PS. It was in SSE2, which means basically all processors today have it. So you can go ahead and just call this directly. It's going to do exactly what we want. So let's just do it. So again, that's mm². And I'm going to use ss in this case because we don't need to do all of them. There really isn't much of a difference between squirt ps and squirt ss. However, in some cases, and you can see it here, for example, in some cases there are either slight performance differences or power differences, like the chip can use less power if it doesn't have to do all the lanes or whatever. There are reasons why you may want to pay attention. So even though it doesn't really matter whether we do all of them or just one of them, in most cases, if you happen to know that you're only doing one lane instead of 4 lanes, or it's multiple lanes, you might as well, right? It just makes sense to not ask the processor to do things you know it doesn't have to do. Okay. Did I do that wrong? What did I do wrong? Set ss, right? And squirt ss takes an m128. Oh, duh. This, obviously I have to actually extract this floating point value now. I don't know if there's, oh God. I don't know what happened there. I accidentally hit like some debug key or something. Can I extract it? Yeah, so unfortunately I have to store it with a pointer. I don't know, I don't remember if there's an intrinsic for just give me the value. I don't think there is, but there might be. Let's see if store, so store doesn't have it. What is the category? Does it say which categories these are in? It doesn't say which category they're in. Because what I basically want is like the one for convert SS. I want one that just returns the floating point value. And I don't know what category that's considered to be in. It's not considered to be in storing. It might be considered to be in round, like a, I don't know if they've got rounding on here. Convert, there we go. So convert or cast might be the right ways to look at it. And let's just see, does anything ever return a float? Here we go. So I think this is all we want. Copy the lower simple to A to dest. Yes, so that's what I actually want. Convert SSF32. So I'll call that here. And then we now have a square root that in theory should just work, right? And it does look like it does. I don't see any obvious problems there. Let's take a look at the profile again. Yeah, again, render volume not good in this case. Still very, very slow, right? Render pieces continues to get better, but render volume unfortunately does not. So not much I can do about that, unfortunately. But anyway, wanted to get rid of that as well. So I don't really know what we can do with render volume. Again, because the optimized version seems to work relatively well, I don't know how much time I want to spend on it, but let me just verify that that is true. Yeah, you know, these are just so low on the totem pole at this point. I mean, basically our whole game takes almost no time, right? Our game is just this down here. And so really the only thing we're still even responsible for that's taking time is the OpenGL render commands, where we are outputting those render commands. I'm not sure why that's taking so much time, and we should probably look at that as well. It could be, you know, because it calls to the driver, or it could be something we're doing stupid. Either way, something we probably want to look at eventually. But that's just, yeah. So I don't know, we could try to optimize that further. I might just say, I guess we don't really care in this case. And we should just let it go. In the meantime, OpenGL render commands is causing us trouble even in debug mode, which is unfortunate. And yeah, that render volume just takes a ton of time, and it would be nice in debug mode if we could speed it up at all. I guess the other thing we could do is just render less volumes. Because the other thing about that is we don't really need those on except when we're doing active debugging. So what I could do is just not do those, right? And so, have a switch for rendering those, turning them on and off, so that we didn't have them up when we didn't actually need them to be up. That's certainly one thing we could do. But in the meantime, let me also take a quick look at that OpenGL, because it turned out to be sort of a little bit of a performance check day. We might as well just go ahead and look at that as well. So if we were to look at the OpenGL render commands function, which is here, this is what we're actually dealing with. And we don't really have any idea what our performance profile is in this particular case. Like, we don't know how many times through this loop we're going. We don't know, how much we're stalling behind any of these particular calls. We really just don't know anything about it. All we know is that we timed the whole thing, and we're getting that result. Now, I don't remember where that timing actually occurs. We'll have to see. So let me take a look at what we're actually timing in there. OpenGL render commands. That's this function, but where's the timer? Are we timing it outside? Okay. So we're timing it outside, and here you can see the swap buffers call getting timed and the OpenGL render commands getting timed. If I wanted to in here, I could definitely do some more targeted profiling just to see, which of these things was doing anything. Something like this. And what I would expect to see is the the quads is where everything's happening. So I would expect to see the lion's share of the time spent in there. If I don't, I'm going to be particularly surprised. Not that that's unusual, but yeah. So you can see here 5 calls to the text, 5 executions of the textured quads block is taking basically all of that time. Now, granted, you can imagine that the time spent in here actually is changing when I'm opening and closing this. The reason for that is because that's actually a call that has to draw the debug system, and the debug system gets tons, there's a lot more quads that end up getting put in here when the debug system is open. And what we can see is every time we call through here, there's a certain amount of preamble, and then there's the actual loop itself. And what I would assume is that because the preamble is only getting executed 5 times, again, I would be pretty surprised to find that the time was being spent anywhere other than the quad loop, right? I would expect this loop specifically, because it's executing on every quad, to be the one that takes all the time, and I would expect the rest of this stuff to be irrelevant. So I'm guessing that if I just time just that one portion, it should take all the time and everybody else doesn't take any, right? And that seems to be the case because now OpenGL render commands is down to 4% of the time, and OpenGL quad loop is at 22. That still seems a little high. It doesn't really make a whole lot of sense to me why all of this stuff is taking that much time. This only happens one time because most of the time we have all the frame buffers. So we're talking about just this and some of this boilerplate stuff here, binding the frame buffers and stuff, is really taking that much time to only do that a few times. It's a little odd, right? But 20% of the time is spent in here, and that to me does make more sense. I'm assuming that the problem is behind the driver because this loop is not really doing very much, but I don't know that that's the case. And so what I'd like to do is verify that the driver is the thing taking the time before I assume that it's not. And furthermore, it would seem like maybe that suspicion isn't really valid, because if it was, then why does it get faster potentially in release mode? Or maybe it's not getting any faster in release mode and everything else is just let's, in fact, we could figure that out. So here it is in debug mode. And there's the cycle count, right? It's like, let's see, 1, 2, 3, 1, 2, 3, 20. So it's like 23 million cycles, right? So let's see if it's still 23 million cycles now. So it is. So what I can basically determine from that is that pretty much there's probably nothing we're going to be able to do about that while we're still in the old school setting textures lots of times, because basically the driver is just thrashing around, hating life really badly because of this whole situation here, right? And that's unfortunate, but that's just the case, right? So what we would have to do if we wanted to fix this is we would have to make it so that the textures, again, were being handled in a more thoughtful way so that they were, in a texture array or something similar. And the reason we're not doing that right now is our textures are all sorts of unusual sizes. So it's not a simple matter to just throw them into a texture array. It's not that simple because texture array elements have to all be the same size. And it's unclear exactly how we would do that, right? We'd have to go to something fancier like a texture tiling scheme for bigger textures, or who knows what, right? So there's a lot of issues at stake there, or at play there, and it's not a simple matter to resolve that. But at least now we do know that that is what's taking the time, which is what we want to see. So at least we know it's isolated behind something that we already know we would want to fix for performance. There isn't like some other weird, like we were copying something we shouldn't have been copying tons of times or stuff like that, that would be causing that slowdown, right? So I think that's about it. I don't know that there's anything else we can really track down performance-wise here that we care about, but at least now we know what the deal is, right? It would be nice, again, if we could make that dispatch quicker, because if we could make that dispatch quicker, we would be much happier. The other thing I suppose we could do is we could check to see if the textures were the same, like if they were the white texture, for example, because a bunch of our quads are going through that white texture, and they, are not going to have that problem where they would have to change textures every time. But again, that doesn't seem particularly relevant because most things in the game will be textured, so it's really just an optimization for things that don't matter. So I would say, but maybe in debug mode they would, because hey, there's like it's drawing these cubes and stuff, and there's lots of those. So you'd save a bunch of time there. But that's really about it. Like that's the only thing I could think of that would really have that case. So we could do something like that. Again, I don't know if we should. If we want to do something like that just to see if it would help in the debug case, it's really pretty straightforward loop-wise. All we're going to do here is say, okay, so we've got a bitmap, and every time we see that bitmap, maybe I'll say here, well, you know what? I can't even do that really because, again, we have this problem of wanting to draw quads. And so we can't really even fix that part of it because we have to do our vertex indices. We can avoid calling bind texture multiple times. And I guess we should just try that, but that's the only thing we can really do. So what we can do here is we load the bitmap up, and what we could say is if bitmap is not equal to last bitmap, then bind the texture, otherwise don't. And is this going to help? Probably not. But might as well check it out. So all that does is, in the case where the bitmap doesn't vary, it's not going to call it. And you can see that it did help a little, maybe tiny bit, but really no, it didn't. So I don't expect that to be, I didn't expect that to be anything special, and it wasn't. I think the fact that we called GL draw arrays so many times is probably just the problem, right? And the fact that we changed the texture probably doesn't help, but the driver probably was already doing something like this, so it probably already did that aggregation, if that makes sense. And so when we do that aggregation, it doesn't help, if that makes sense. So I'm guessing that that's just a meaningless optimization that we don't need to preserve, right? And I'll just verify that. Hold on one second. So here's us calling it every time in debug mode. So yeah, well, you know, it's not nothing. For whatever reason, us doing that manually, I guess the driver does enough work behind that bind texture call to even detect whether or not the texture is the same, that it does actually flatten it a bit. It's not really that great, but it's, you know, it's something. And again, we could get rid of this GL draw arrays if we had a way of drawing quads instead of triangle strips. That would be something that we would do here. Unfortunately, we can't really do that without introducing a geometry shader that would produce triangle, that would produce quad index groups for us, and we don't really have that infrastructure in place. We could go at it. It's not hard. But I just don't know if that's worth it at this point. But yeah, what we would end up doing here, again, is this same sort of situation, if the bitmap were not the same, right, is instead of actually issuing the GL draw arrays call, we would sort of stack them up. So we would do something like how many indices, or really how many, you know, what's our draw vert count? And then what we would do every time is when we did the switch, we would say, oh, okay, you know, every time we do the switch, we need to bind, or we need to do the draw arrays with the number of vertices that we have. And each time we come through here, we need to increment the number of vertices we have by 4, right? So in other words, the first time through, we would pick out the bitmap, we'd see, and you know, I'd probably want to put a check here that was like if draw vert count is greater than 0, then we do the GL draw arrays, otherwise we don't. Then we do the bind texture, and we set the draw vert count to 0, right? And we can do the bind texture right before the call too. We could do it this way by calling last bitmap, right? And off we go. So we could basically say if bitmap's not equal to last bitmap, then you know, if the draw vert count is higher than 0, bind the texture and draw the arrays, then do last bitmap equals bitmap, and off you go. Every time we end up with 4 more vertices, and then at the end we would need to do one more, right, just to, you know, basically clear it out. So we have to say, okay, if the vert count is greater than 0 at the end, right, which it almost certainly is going to be unless we didn't have anything in the loop at all. Then we have to do the last bitmap bind and the draw vert count, right? Now the vertex index that we're on, in this case, is not going to be accurate. It's going to have to be the old vertex index that we would have started with. So we also kind of need to track how far back we have to go in some sense, but we kind of know what that is, right? So we know we're stopping on this one. In fact, you know, a smarter way to do this, actually, now that I think about it, it's probably a lot cleaner, is just to say like first vert, right? And then what we would do is every time we draw, we would say like first vert equals vert index. And so then all we would say is, well, you know, you always draw, oops, I guess you can still leave it this way. This last one's a little more complicated. But as we go here, we're going through the vertex indices. The draw vert count is basically just wherever we are in the index stream minus wherever we are when we started is the number to draw. If that's greater than 0, then we just draw it, starting from first vert, and we draw as many as there are, right? As many as we have to go to catch up. We then store where we are right now as the new first vert. We don't have this at all anymore. And we just keep going from there. At the end, we would do the same thing, right? And we just need to know what that vert index is. So we need to have that be an actual, more like a while loop now, right? That's going to work like this, so that vert index actually equals what it should equal at the end, right? But that's it, and then it's going to be doing that drawing. Now there's a problem. Oops. Well, two problems here. First of all, these both have to be the same thing, or rather I could just do this, so it won't draw the first time. The problem here is that we will get garbage now. And the reason that we get garbage, again, is because of that quad situation, right? We don't have a way of generating quads, so we're generating triangle strips, which means at the end we'll always connect every sprite to every other sprite as we go, right? But interestingly enough, you can see that that really dropped dramatically the amount of time spent in the quad loop, right? Here we are. It's been flattened down. It's about twice as fast as it was when doing those calls. And again, that's because just eliminating the number of times we ask the driver to draw things by drawing things in batches, right? Now, I'm going to just back out all of that because, again, I don't really think that's particularly useful. It's not, there we go. It's not really anything that it's not really the appropriate optimization. I think the appropriate optimization is to figure out how we might use texture arrays here to avoid that overhead. And again, the problem there is just that that has a bunch of asset implications that are really kind of nasty. Basically, what that means is that if you want to use a texture array there, you get into a situation where you have to make all of your textures fit into a particular size. So basically, you have to pick a size like 1024 by 1024, and you have to pack all of your sprites such that they fit inside that texture. And if you have multiple of them that are relatively small, you would need to make sure that they fit. Maybe pack them into a single one as like a texture atlas or something, because you don't want to waste the space since the memory is at a premium. You have all of these issues you got to address once you go to texture arrays that are kind of nasty. But that is what you would want to do to make that loop actually run in a reasonable fashion. And the biggest problem that we would have right now with that is the cutscene art, because the cutscene art is large, and we would basically need to tile it, right? We would have to break it into some tiles in order to draw it on, the way that we're drawing it at the moment. And so, yeah, I really just don't know if we want to deal with anything like that. What we could do, I suppose, is something like all of the in-game sprites we could put in a texture array, and the cutscene art we could leave outside the texture array. Because the cutscene is a very special case scenario, and like the cutscene, if we flip over to it here, is not ever going to be in the performance critical part of things, because all it's doing is just rendering some basic stuff. And you know what? We have never updated our cutscenes to work with the new 3D system either, have we? That's probably something we should do. Maybe that's something I'll do right now. So, maybe we could just do something different for them. I'm not sure. It's hard to say. So I don't really know what we want to do there, right? I don't really know what we want to do there. It's a good question. But we definitely have the circumstance where it's like, yeah, okay, like, Could we just slam all of our in-game art into a texture array and presumably they would fit without too much hubbub? I don't know. Let me take a look here. So if we had a 1024 by 1024 texture, because there's no in-game sprites probably bigger than that, times 4 is what, 4 megabytes of textures. So, you know, if you assume half a gigabyte on the graphics card is a reasonable minimum platform, so then you're talking about, what, 128 of those, right? That's just not very many sprites. So at the very least, we'd probably have to say that all sprites were 512 by 512, right? And I mean, we could turn on DXT texture compression and get 4 more times in there. But so then at that point, you know, we would get 512 sprites images in the cache at once, right? And it's not very many. But, you know, maybe it's enough. I mean, it is a cache after all. 512 unique images on the screen, I don't know. So 256 by 256, if we crammed everything into there with no texture compression, yeah, that's 262. So, you know, if we did say, well, we've got 512, let's say we've got 512, oops, 12. 1024 times 1024. So we have 512 megs to work with on the graphics card. And we want to divide that by 256 by 256 by 4 for sprites. 2048 sprites is a lot better in terms of how many different sprite images we could have in memory at once. But the resolution's not great. Like 256 by 256 sprites isn't huge, but you know, we could do it. If we were in the mood to do it, we could do it. So maybe we should be in the mood to do it, and maybe we should do that because, hey, that would get us into a much better place performance-wise. I don't know. I really don't have a strong opinion about that. Maybe we could take a poll. What I can say is that regardless, a reasonably productive use of our time at the moment would be to go ahead and fix the cutscenes. Because, I mean, you were going to want those to work either way, right? So let's just go ahead and fix our cutscenes. And here's how we're doing the cutscenes. You can see we've got sort of them coded in here as just what layers we want. And the layers, as you can see, they're already like pre-sorted, right? So the furthest away thing comes first, and then the closest thing comes as the last one. So they're capable of being drawn in order is basically the only important part about that. And you can see here, I guess it never draws the first layer index, it looks like, for some reason. I'm not sure why that is. Scene layer count. Oh, and it looks... That's a very interesting loop. It looks like we were previously drawing these in the other order. I guess just to match the layer tags in the bitmap matcher, but that's just kind of a weak... You'd think you'd put +1 here. But either way, it doesn't matter. You can see us drawing them here. We are drawing them in order. And so as we draw these and we push the bitmaps on, we should get the transform z here minus the camera offset z being computed. That pz, as far as I know, I don't super get why we aren't seeing. Let me take a look here. So these look like they're coded I guess I don't know how we've set up the camera, but if you take a look at how we set up our z values, though, we did do it so as they were coded how far away from the camera they are, right? So that z value there is really not what we would normally think of as a z value, because z goes up in our game. And so when we set the camera transform here, you know, we've got the z values going the wrong way round in terms of distance from the camera. I'm not sure how that was working originally. It seems a little weird. Did we account for that somehow? Because you can see here, like, this is supposed to be the furthest away, but in our game, z comes towards the camera. So setting this to 300 doesn't really make any sense. It's supposed to be negative 300, right? But I don't see anywhere where this is getting negated. So it's a little bit weird what's happening here. I'm not sure how to interpret that, or I'm not sure I remember, because it's a long time ago when we did this, why we weren't taking steps to rectify that, right? It's just really strange. So I also don't know what the camera offset z stuff is for. So looking at this here, you can see like intro shot. You can see here our camera information, I believe, is what's you know, being encoded there. So you can see here we've got layered scene. So these are those things, right? There's the let me see how we got it here. Intro layers index. So we start with the asset ID, which is this one. And then we have the shot index. Then we have the layer count. Then we have the layer pointer. Then the next thing is the duration, which is this. So 20 seconds, right, or whatever. We then have in here we've got where the camera is supposed to start. And then we have here where the camera is supposed to end, right? And there's also a fade value, but only one person uses that, which is the first one. So if we take a look at what's happening here, the camera's starting at 10 and it's going to 5 for a zoom in. And again, that's like correct if you're trying to zoom in. 0 going to -4, also correct. 0 going to -1.5. Those are all proper zoom values in the distance space of the game. So what I don't understand is how these values... Oh, I see. Those are actually like used for some other purpose. These are the actual z values, I guess, because those properly line up negatively, right? So what are these values here? That's more what I'm interested in. So that's the height value is all that is. Okay. So these are still, I was just taking some time to get back familiar with how these are encoded. That's actually fine. So what I really want to know there is if these are being drawn properly from back to front, I don't really understand what I'm looking at. I guess the problem is probably alpha to coverage in this case. Let me find out, though. You know what I should do first is let's not start into game mode. So if I go to handmade.cpp, I'm pretty sure we can just turn this off and we will start up with the title sequence like the game would in reality. So like looking at this, you can kind of see I don't super understand what I'm seeing here. This is confusing to me. The reason it's confusing to me is I have this whole portion of this image here. The alpha for this part of the image should be 0, which means I should be seeing through it. Even with alpha to coverage, it should just not be affecting what's underneath it in that way. If there was anything being drawn underneath it at all, but even if there wasn't, it should still work, right? And so what I don't understand is it seems like the Z buffer is getting set there in a way that doesn't make a lot of sense to me, or something weird is happening. And I really just do not understand it. So one thing is, I don't know what the Z clipping range is here, but it could be that the Z clipping range is too aggressive for where these are. So, 300, what's our near far clip plane? Right? So if I go here to perspective, projection, well, there's your answer, right? So our near clip plane is at 0.1. Nobody's in danger of violating that. But 100 is certainly going to clip out a bunch of these saucy gentlemen here, I guess. 200, 170, 100, not going to work. Can't see if there's anybody else here who wouldn't work. Most of the other ones should be in line. So that would really only explain a couple of these ones, right, that we have. But that's definitely the case. And so one of the things we might want to think about in here is starting to say, well, maybe we want to be able to specify the near and far clip planes in some kind of a more reasonable fashion. So let's go ahead and take a look at what we would do there. So inside render group, when we have set camera transform, what we could do is just tack those onto the end. And then when we call perspective projection, we can just pass the near clip plane, the far clip plane. We call orthographic, we could pass the near clip plane and the far clip plane. And then when we go to handmade math, we could just do like so. And so in same thing here, now that's parameterized. And so we're going to want to do this in two places. So in the debug system, when we do set camera transform, this is now going to want to specify these two. So it's going to want to specify those clip planes like so that we have that nice big region that we were expecting. And everybody else will be fine. What is this complaining about? What is it, that the position that has to get set there? Tell me, please. I assume it is the position, but let me find out for sure. Yeah, camera P. So now we should be fine for this as well. I just want to make sure that all the Z still works there. It does. So now in the cutscene case, we can specify a near and far clip plane that are more amenable for what we are trying to do. We don't actually want to change any of these. We want all these to be the same for the moment. But the near and far clip plane in this case, we want to be more generous for the cutscenes, because that's just how we encoded them. And now we can take a look and see if we get any more reasonableness here, although I don't really see us getting any more reasonableness. So, and again, the weird dimming effect that we get here is not explainable by clip planes no matter what. So that's also kind of a separate issue that I don't really know. Oh, you know what? That's our distance-based fog. Right? our distance-based fog, we don't have a way to turn off. Right here we are, when you do perspective projection, we're set this fog distance as well. So we also need that. We should probably have a better way of passing these parameters, because there's just too many of them at this point, right? And maybe at this point I'll just do a B32 that's like fog equals true. Or maybe equals false. And so that way I could come in here and say, all right, well, you know, if they ask me for fog, then turn on fog. If they didn't ask me for fog, then don't turn on fog, right? And then inside world mode, when the one person who actually wants it, thought it was here, set camera transform. There it is. So I think that would also get us out of the business of doing this switch, which is kind of nice. So what we could do is say, like, all right, it's always negative camera Z in the case we wanted fog, and just when you know, let's do near clip plane, far clip plane, false, right? Near clip plane, far clip plane, true. What we can do here is say, well, let's encode the near and far clip planes here. And off you go. So in theory, that should give us now the ability to turn off the fog, in this case. Although I guess that, now that I think about it, that's not important because we'll get a default value of false there. And so now at least we're in a much better scenario where we're looking at the cutscene and we can at least see all the pieces of it. And nothing's getting clipped now. Which is also nice because we have a proper near and far clip plane, so that's also good. And presumably all this stuff is still working as well, and yeah, it does seem to be, so that's good. And so now really our only real problem now is that our depth of field has changed quite a bit with the way that the projection is working here, so our camera, like our FOV and stuff, all seems wrong. I don't really know why that happened. I'd be lying if I said I really had any idea what was going on there. That scene's going to be wrong because the near clip plane, and we'll have to take a look at what's going on there a little bit later. But all the rest of the scene should be fine. So what we need to do is kind of restore that focal length, I guess. And I'm not 100% sure, like I said, how that got undone. I really don't know. So, yeah. Yeah, I just don't really know what the circumstances were here in terms of how this was previously, what stuff in the old sort of transform system, what it was actually trying to do. So I'm just going to fuss with it a little bit here and just figure out what maybe it was trying to do so we can get a little bit more involved in that. Now, so I don't know what this is. We don't even need this anymore. If you look at camera frames, it's not even a thing. It's just focal length is focal length. So we can just set focal length to something here, you know, whatever it ends up being. At the moment, it's set to 0.25, and so that's fine. It just gets set down here, and nothing happens. But I am interested to know what will happen if we change that focal length. Were we sort of thinking there was a different focal length? So suppose I change that focal length to 4, for example. You can see we get closer in and perhaps a little bit closer to what we were expecting. Originally, here's a closer focal length, and again, that's even closer to the image that we were originally expecting to have, which was a much closer in version. This one, again, looking pretty good here. I think maybe mostly what we had happen before is we did it with a focal length that was more akin to this. And so now that's what we're looking at. I don't really know. You know, I also don't know when we were supposed to stop. How long has it been since I've been streaming? What did I start at, 11:30? I was supposed to stop like 20 minutes ago, wasn't I? I don't even know. Yeah, okay, so stream's over technically, and I'm still going. I don't know what happened. I apologize for that. I just got carried away. Anyway, point being, the focal length setting might be the only real thing we need to fix there in terms of getting the scale right. I'm just not 100% sure. So again, looking at that, that's a little bit too low in terms of where we were supposed to be zoom in wise. Let me go ahead and just try a couple more values to see if any particular value looks like what we had tuned it to before in terms of how we had wanted those scenes to appear. It honestly looks like something very close to 8 is probably what we actually used in terms of where we wanted those cutscenes to be. It's a little bit hard to tell, but it seems correct. We still have to fix the window sizing there. So it kind of seems like, for the most part, this is more correct. And so really the only problem that we have at the moment, so, you know, I guess you might say there's two things we'd probably want to fix. One, these cutscenes would look a lot better if we did not use alpha to coverage. So if we just had a way of turning alpha to coverage off at this point, that would be helpful. And the other thing is we have everything hitting the near clip plane, I believe, in this particular scene. So all of these are a little bit off. Where Santa Claus went, I don't know. It might be that his Z is set wrong, but I'm not sure. Let's take a look. I don't know which scene that actually is. So there's that. But let's see here. So we've got here Skywall and Icicles, here in Tree. So I believe it's this. Krampus is next, right? I believe it's this one. And these both have the exact same Z. So that does seem like maybe that's a problem, but maybe they're just in the wrong order. Oh wait, no, these are the same flags. So these should be sorting properly. I don't know what's going on there. I don't know why we're not seeing I don't know why we're not seeing those values. Let's just take a quick look, because I'm already over time and who cares? No one cares. We need a quick way to set this to like large values, right? We use it enough that I don't think it's a waste of time. Test some better UI in there. Oh, I can't pause, can I? That just pauses the profiler. Of course. We don't really have a global pause working anymore. So many things we should probably go fix in there. Anyway, the problems of only having a few hours every week. All right, so yeah, I don't really know what's going on with that particular one. It's a little weird to me that that's a problem, because it looks harmless enough. And so you would think that it would be fine unless it has something more to do with these x offsets here. So the fact that this is marked a transient just means that it'll only show up between these two time values, right? So there's nothing particularly weird there, and we know that that system is still working because if you take a look at the scene immediately subsequent to it, you can see that that one also relies on a bunch of transients, and it's fine. So I'm not really sure what's going on there. I don't know why it would be having that problem. Now, what I would like to do is I'd like to make this be the first scene. So I think what I can do there is just say like, oh, well, you know, let's just force it to be first. Right? And so at least then what I could do is I could go into cutscene and see what's happening. Right? So let's see how many layers it thinks there are. Where are we? There we go. So we've got layer index 1, and we've got layer count of 5. Here we come through here. We're looking at this layer. So here's the transient. Active is 0, and active is 1. So we do know that we draw one of the transient layers, which is exactly what we expect. We'd always expect to draw at least one of the transient layers. We get the bitmap match back. It's a real bitmap as far as we know. We go ahead and prepare the transform as we normally would. And here is that transform. Here's the offset P. It's in a reasonable location, right? Negative 3.7. And again, it's really only the x value that's at all unusual there. And I mean, I'm assuming that's correct. We don't really know. But I don't know why that would be at all bizarre, right? In theory, that should just work. I guess one thing I don't know is, are these being rendered as upright or not? I would like to find that out. Let's make sure they're not being rendered as upright sprites, because that would potentially create this problem due to the Z offset. So they're not being rendered as upright, which is good. However, when we come into push quad, after packing all of these things in here, yeah, all of the W values are properly 0, it looks like. No, they are not. Okay, so that is also a problem, right? Because these are supposed to be flat, they're not supposed to be upright. When we bind this Z-bias in here, the Z-bias is only supposed to be for upright sprites. So this has been a bug like the entire time We just haven't had any non-upright sprites. So probably what was happening there, and this is exactly what I thought might be happening, which is why I went in. It's funny that it actually was true, because it was really just a hunch, is since this bitmap starts lower down, its Z bias will be increasing as it goes upward, and Santa Claus starts right here. The Z bias in an upright sprite in the shader was enough to make its Z value be higher than Santa Claus by the time Santa Claus started. Because remember, even though Santa Claus starts in front, his height his Z bias is going to start increasing only at a certain point on the screen where he begins. So it looks like the problem there is just in render group, we never properly handled flat sprites. The Z bias should only be happening here. If the sprite is not a sprite that stands upright, it should have a Z bias of 0 and not of any other sort of like stand-up value. Okay. So now our Santa Claus is back. Everyone is happy. And now I will go to the Q&A because I'm not going to try and fix the near clip plane thing yet. So let's go to the Q&A. So Handmade HeroBot is really dead for real, right? Desu's asked, what will be our way forward to reduce GL draw array calls? Will we look into texture atlases, megatextures, or invent our own way? Is it better to separate cutscene rendering because it's so different? The answer is we don't know that we need a way forward yet. In other words, like we don't actually have any performance problems with this yet. We only were looking at that as being a source of time that mattered because our debug frame rate was not 60 frames a second, but our non-debug, our release mode frame rate is 60 frames a second. So we actually don't have a problem to solve yet, right? And so before I would look at anything more complicated there, we have to actually end up with a frame rate problem we have to solve, which we don't currently have to. Kylo asks, are we forced to use SIMD registers to use those intrinsics, or are there some ways to do that without those, like inline assembly or something else? So I guess what I would say is I'm not 100% sure if I understand the question. So I'll just start with a bit of background, and you can stop me if this is not answering the question. On the original x86 architecture, it did not have floating point operations. So you only had integer operations as far as manipulating numbers are concerned. They then added a co-processing unit called the x87, which had floating point operations for the first time. And those floating point operations were done using a special set of registers to hold floating point values. So when you wanted to operate on floating point values, you had to put them into those registers. And when you wanted to transfer, if you wanted to round them back to integers or something, you had to move them out of those registers using instructions for doing exactly that. So anytime you operated on floating point values, you were going to use the x87 stack. You put them in there, you operate on them, and you move them back, right? Now there's you don't have to necessarily load them into regular processor registers first. You can load directly into the x87 stack, and you can store directly out of the x87 stack to memory as well. So it's just another set of registers, but they were the registers for operating on floating point floating point values. When SIMD instructions were added to the x86 architecture, a separate set of registers were added for wide floating point operations, right? the XMM registers, and those registers are separate from the x87 registers. So now, when you did floating point operations, you had a choice of putting things into one of two registers. One register set was the x87 stack that you would use if you were trying to use x87 floating point instructions, and the other one were the registers for SIMD instructions that you would use for executing floating point units. But again, in no way were you ever doing floating point operations in the main set of registers, because the general purpose registers don't have the capability of doing floating point operations at all. Once they moved to the x64 architecture, they got rid of the x87 coprocessor concept altogether, because again, it hadn't been a coprocessor for quite some time. It was simply just the old instruction set that the coprocessor used to use had been sort of welded in and now just was used on the chip always. They got rid of that and only have the SIMD registers. So single floating point operations are now still done on the vector floating point unit, because the only floating point registers that are on the chip are wide floating point registers. There is no x87 stack anymore, or x87 instructions, as far as mainstream x64 processor use is concerned. So, the reason I don't quite understand the premise of the question is, when you say, are we forced to use SIMD registers to use those intrinsics, or are there some ways to do it without those? What I would say is, well, what do you mean do it without those? There's only one set of registers on the processor for doing things like square roots or any kind of floating point operations at all. Just even adding two floating point values together, there's only one set of registers for those, and that are the XMM registers, right? So I'm just not sure what you would even be trying to avoid. If you're doing floating point, you're using those registers. They are the registers you want to use. There is no reason you would want to avoid their use. That is all they're there for, and they are the only thing that is used for floating point operations in that way. Desuse, have you seen MUSL standard library? It has very good code quality. Square F on x86-64 is one instruction on it. It's for Linux, but parts of it are very portable. No, I haven't. MUSL. I can take a look. Oops. So here we are. Well, that doesn't really seem to be like source code to the x86-64 version. Oh, are these directories? I don't know where to go to get the actual code. I don't know where the code is, unfortunately, so I can't really look. Okay, here we go. So I don't know where the floating point stuff would be, for example. Math? Wow, they use one C function per function. That's some aggressive work there. So that's not an optimized version. So how do I look at like the optimized? That's like a C version. I don't know if maybe there's, yeah. I'm not sure how to get the specialized one. Maybe it's also in there, but under something like, there it is. Yeah. Let's check out ATAN 2. What? What is this? How, that's not, those don't exist anymore, do they? Can you call FP8tan from x64? I mean, I guess you could. But if you did, your operating system has to be restoring the old x86 stack, which I don't think it does on Windows, does it? Maybe it does. Yeah, I don't know about this, man. This does not look good. That is not probably a good way to do an FP8tan on a general. I don't know about this, dude. I'm not getting a good feeling about this. You know what I'm saying? Do you know whether the squirt function in math.h uses processor instructions or calculates results via some software algorithm? I don't think I understand the question. I mean, a software algorithm would still use processor instructions, right? Do you just mean, does it use squirt PS? And we showed that on today's stream. It does eventually call underscore mm underscore squirt underscore ss. It does eventually do that in the C runtime library. So it just does a bunch of preambles first, right? It does a bunch of checks to see first whether it needs to be in a special case, probably for like for NIAN or something. I don't know what it's checking for actually. -1 maybe, negative numbers. And maybe the C spec requires certain things to happen on negative numbers. I don't know. But it was doing a bunch of preamble, but then eventually it did get down to actually just calling squirt. The squirt instruction, which I never remember what it's actually called. The intrinsic's called one thing, but the actual instruction on the chip. Intel gives it a different name, squirt SS. So squirt SS is what the processor did in fact call. So the C runtime library is in fact using it. It just only uses it after doing a bunch of unnecessary work for our purposes, which I believe were for checking for for error conditions. And yeah, if you go back in today's stream and watch where I stepped into squirtf, we saw it call squirt ss. So it is actually calling that in the C runtime library. It just does a bunch of unnecessary preamble, probably to conform to spec error reporting standards or something. All right, let's go ahead and close it down. Thank you, everybody, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. It comes with a source code so you can play around with it. We also have a forum site you can go to ask questions, a Patreon page you can go to if you want to support the video series. a schedule bot that tweets the schedule at you so you know when we're going to be live, and an episode guide so you can go back and look at any previous episodes we did, and it has all kinds of great annotations and stuff, so it's easy to find things. That's about it for today. I'll be back tomorrow for another episode where we will probably just go back to doing the camera stuff, since today we kind of had a little bit of a diversion fixing some things, but it's nice to fix things. That's about it. Thank you for joining me. Until tomorrow, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.